Yes, Sat Shri Akal students. Today our topic is reactivity series. Just like students, you have seen some students are ready to fight anytime. Some students are ready to fight when they are disturbed, and some students never fight. Just like that, there exist categories in elements which are lustrous, which are hard, which give electrons, which are known as metals. Some of the metals are highly reactive. Some are on an average reactive. Some are very less reactive. So we are going to discuss what is reactivity series. Now, this reactivity series, students, can also be compared to number line. How? This chemistry and maths is related. On number line, students, the numbers, let's talk about integers. Integers which are on the left hand side to 0, they are chota, they are small in size, which are on the right hand side are bigger in size, not just 0 anyway. Let's say, even if I compare these two numbers, this is on the right hand side, this will be bigger. Here is 1, here is 2. 1 is on the left hand side, 1 is smaller. Now, see students, some think that if I say potassium is the most reactive metal, most reactive, so much reactive. If you have some water, you put some potassium and water, it will explode. You can see videos on YouTube. Potassium and sodium thrown into lakes, they explode. They are so reactive. Why? The answer makes you more interesting in chemistry. Both sodium, which is number 2 in reactivity series, and potassium, which is on the top of reactivity series, the most reactive metal, potassium. But why they are so reactive? The answer lies in octet concept. What is this concept? You know that on one side, in human beings, we have saints. They don't want to give anything to anybody. They don't want to receive anything from anybody. Like that, we have noble gases. In chemistry, noble gases, they are not ready to react. Talk about helium, krypton, argon. Their octet is complete. What is great about octet? See, students, the outermost orbit, either if it has 2 electrons, like in case of helium, or other case, let's say we talk about element having atomic number 18, its electronic configuration will be 2, 10, 8, octet, complete. In the last shell, there are 8 electrons. So it's very stable. It's like sands. It doesn't react. And that's the reason when the welding is done at very high temperature. And there are some environmental hazards for welding. When two metals are joined at very high temperature known as welding. So a covering of noble gases is given. Why? So that the atmospheric gases should not react and make some dangerous compounds which are not good for breathing. That's why a cover of noble gases is done. Why? Noble gases are like saints, they don't react and they don't allow other gases to react also in their environment, or we say in their vicinity. In their vicinity means the volume or the space where they are present. ਉਹਨਾਂ ਦੇ ird gird, ਉਹਨਾਂ ਦੇ ਆਲੇ ਦੁਆਲੇ ਉਹ react ਨਹੀਂ ਕਰਨ ਦਿੰਦੀ. So students, I was comparing the reactivity series with this. Now, 2 is bigger. Anything on the right hand side? 1 is smaller. Now, here in reactivity series, let me first complete it. Potassium, then sodium, then calcium, then magnesium, aluminium, zinc, iron, lead, and then hydrogen element, copper, Hg, Ag, silver, and in the last, Au. It doesn't want to react. Gold doesn't want to react. But still, it reacts to some extent. It's not like noble gases, not at all ready to react. Here, this sequence has similarity with the numbers on number line. Means we can't say Mg is reactive, very reactive. It's all relative. Means now on the left hand side, the number is smaller. Below, its reactivity will be less. Means Mg is less reactive as compared to calcium. But Mg is more reactive as compared to aluminium. Wow. See, 1 is smaller than 2, but 1 is on the right hand side of 0. That means 1 is bigger than 0. Just like that, students, zinc is more reactive than lead, but zinc is less reactive as compared to any of the metals above it: aluminium, magnesium, calcium, sodium, potassium. Now, we say sodium is very reactive. It reacts very fast. We have sodium and we have HCl. They are bound to have NaCl ionic bond plus H2 gas. 2 here and fine, we get, 2 here, 2 here. It's balanced. So NaCl, NaCl, the bonding is, the attraction is very high, affinity is very high. Why? Na wants to complete the octet. I'm coming back to octet. So Na has 1 electron in the outermost shell. Somehow it wants to give away this electron. And on the other hand, chlorine, the extent of reaction in terms of giving electron is same as extent of reaction in terms of taking the electron. Why? Because chlorine atomic number is 17. In order to complete its electron, it wants, in order to complete its octet, it wants 1 more electron. So 17 becomes 18. This octet is complete in chlorine. Here, in case of sodium, what is the atomic number of sodium? Anyone? 11. When 1 electron is missed, it becomes 10. And 10 electronic configuration is 2 and 8. Again, octet is completed. This octet concept, if you understand, you can understand a lot of reactions in chemistry. Most of the reactions happening in chemistry is a tendency to complete octet, means more stable. That is the same reason, students, if you have jug of water and if you throw the water will come down. Why? Because at a height, the potential energy of water is high. It's unstable. When it drops down, it comes to ground level. Any student? Its potential energy is reduced. And when it comes to the surface of Earth, it is further reduced. And if you say on surface of Earth H is equal to 0, you can say potential energy also becomes 0, though it's a relative concept. So you see how this physics, chemistry, and maths are interrelated in this reactivity series. Well, in this reactivity series, again, you can say copper is more reactive as compared to any student,
Mercury.
as compared to mercury, as compared to silver, as compared to copper. But that doesn't mean copper is very reactive. It is very less reactive as compared to calcium and somewhat less reactive as compared to, I told you yesterday, this is hydrogen. If I simply write H, what does it mean? Hydrogen
Element.
Once you understand and memorize this reactivity series, it will be very easy for you to understand double displacement reactions and displacement reactions. The metal which is more reactive, it will displace the other metal. If it is less reactive, it will not be able to do displacement reaction. All right, students. Just like that, this reaction is also displacement reaction because you see, Na is more reactive as compared to hydrogen. See, Na is on the top of hydrogen. Had Na be below hydrogen, this displacement reaction would not have happened. So students, stay tuned. Share this video with your friends who are interested in learning concept, not doing work like a parrot, taking homework of others and just keeping it in your copies. Thank you very much. Have a nice time.